Okay, so we practiced how to do an analysis for a simple project, right? We listed all the path, we identified the critical path, and the critical path duration is the project duration. Now, what can we do when we have complex projects where we have thousands of activities? So certainly this manual calculation that we have done is not practical. And we use, of course, computer softwares to do that, but it's very important for you guys to learn what are the calculations that underlie these softwares. And these are algorithms, meaning that these are steps of calculations that you do in order to come up with the project duration, the critical path, critical activities, etc. So what do we do? These algorithms will enable us to find for every activity 4 pieces of information. The first one is called the early start. What's the early start? This is the earliest an activity can start. Okay, so you should be able to tell what determined that time for any activity. Think about it. What determines the earliest time an activity can start is, of course, the completion or the earliest completion of its predecessor, of its immediate predecessor, right? We already discussed that concept before. Now, the second piece is the earliest finish. What's the earliest finish? It's the earliest time an activity can finish. That's it. You cannot do that before. So also think about that. If you already know the earliest start, what can be the earliest finish? What determines that? Yes, it is the duration of that activity. Now, we have 2 more. We have the latest start. What's the latest start? You know, we already defined the earliest start, but we also can allow an activity to start at a later time, not at the ES, at a later time, but in condition that the project will not be delayed. So if we have this room of flexibility, then this activity can have a later start other than the early start. Okay, we're going to show that in a problem, in an example that we're going to do the calculation soon. Then we have the latest finish. The latest finish, also same concept. It's the latest time that you allow an activity to finish without delaying the whole project. Okay, the question is, how can we calculate these 4 pieces? Very simple. We're going to learn an algorithm, set of calculations. And these comes in 2 passes. We call a pass. What does it mean, pass? When you go from one point to another point in calculation, we call that a pass. So we'll do a forward pass that will allow us to find the early start, early finish of every activity. Then once we have all these, we do a backward pass. Okay, so we start from when we ended the first process, okay, the forward pass, and we start from there, from where we finished, and we go back to where the forward pass started in the first place. All right, we're going to see that anyway, don't worry. So we're going to find the late start and the late finish at the end of this pass. All right, so let's see how these 2 passes work. We're going to start with the first one, forward pass. So it's forward pass start from the starting node and ends at the ending node. All right, so we're going to do the calculation first for the starting node, the next one, until we finish at the ending node. Now here I need to make it easier for us to record our calculations, better to represent the node like that. So we're going to split it into 3 parts, sorry. On the left hand side, we're going to find the early start and then later the late start. In the middle, we're going to write down the activity name or letter, and then the early finish and the late finish on the right hand side. But since now we're doing only the forward pass, we're going to find only the ES and the EF. So the procedure is like the, and by the way, sorry, we're going to show the duration also in the middle part. So the middle part is always a given data about the duration, about the activity, sorry. So we have the number of the activity and the duration, which is given. Now the procedure is like that. We need a starting calculation, right? How do we do it? Since we're starting the project now immediately, so we set the early start of the first activity, the starting node, as equal to 0, right? So we're telling the project start immediately now. Now, for any activity, the early finish, as I mentioned before, all right, the early finish will be equal to the early start plus the duration, right? So if we're starting now and this activity takes two days or 2 weeks, that means its early finish is 2 days or 2 weeks. Now, when we are moving from one activity to another activity, if an activity B has only one immediate preceding node, that means the early start of activity B will be the early finish of A. Look at this. So if I have two activities, A is an immediate predecessor of B. So if I find out during my calculation that the early finish of A is, let's say, 3, that means this will be the early start of B, right? Because B needs to wait for A to finish. So once this is done, this can start. So that's very straightforward. Now, it can be a little bit complicated when an activity B has two immediate predecessors. Okay, or sorry, activity C can have two immediate predecessors like that. So C needs to wait for both A and B to finish so that it can start. So let's say A will have an early finish of 4 and B early finish of 5. Think about it. When C can start, very logical. It can start only after week 5, right? Because yes, after week 4, A is completed, but still C has to wait for B, right? So that would be then the early start of C. And this is what we're saying here, that then the early start of a node will be the largest of the early finish of all its preceding nodes. So let's apply that now on our famous bank project. So this is the PND that we did before, and you notice here that I split every node into 3 parts, and I'm going to add the duration in the middle part. So these are durations given to us, and now I need to start. So where to start? Remember, we said you set your early start of the starting node, and in this case, it's a virtual node, right? It's it's S that we added. So we set that as equal to 0. Here we go. And of course, the early finish, 0 plus 0, it will be 0. Then I need to move to activity 1, which has one immediate predecessor, S. So that means the early start of 1 is what? Is the early finish of its immediate predecessor. So that makes then the early start of 1, 0. And then what will be the early finish? 0 plus its duration 8, it will be 8. What about activity 2? Think about it. Yes, same as in 1, its early start is 0, then 0 plus 4, it's 4. Then we move on to activity 3. It has also one immediate predecessor, so that's straightforward. The early start will be equal to the early finish of 1, which is 8, then 8 plus 6, 14. For activity 4, also one immediate predecessor, so also 8 here, 8 plus 11, 19. For activity 5, one immediate predecessor, that's very easy, so 4 plus 9, 13. Activity 6, 14 plus 3, 17. Now activity 7, this can be a little bit tricky because it has 3 immediate predecessors. One can be completed by week 17, one by week 19 at its earliest, and one by week 13. So when do you think 7 can start? Yes, it can start only after week 19, right? Because it has to wait for the 3 of them to be completed. So here we go. It's 19 plus 1, 20. And 20 is your project duration. You found it. All right, next we're going to do the backward pass.